Variable speed drives or variable frequency drivers is the second most important technology when it comes to programmable motor controllers. An electric motor at startup generates a lot of torque within itself, and that causes a lot of strain in the housing of the motor. Motors are locked with respect to their speed because of two aspects. We all know that the synchronous speed of a motor is dependent on the frequency as well as the number of poles, pairs per phase. Because the motor is standard, the number of poles is locked. So if I want to change the speed of rotation, I need to alter the frequency of the electric signal that supplies it. And that is where the variable frequency drive or the variable speed drive comes into effect. Typically, a variable frequency drive or a variable speed drive, when connected to a motor, will start off at a low frequency. As a result, we'll have a low speed on the motor, and then it'll pick up over time to increase the speed of the motor, and that will save the motor from excessive strains. Now, in essence, the way that a variable speed drive operates is it is supplied by three-phase supplied by the three phases. I'm going to do this last one in yellow. I hope it's visible. Looks okay. Then this goes into a converter. Now what the converter does is it converts these three phases into three single DC voltages. So we've got the yellow at a constant voltage, we've got the blue at a constant voltage, and we've got the red at a constant voltage. These three voltages are all equal in size, and then this is sent to an inverter or a pulse width modulator. We'll look at that in a little bit more detail. And then what this does is it takes this frequency, which is typically 50 Hertz from our supply, and it changes that to a frequency that we can use to then alter the speed of rotation of a motor. This is your basic operation and the basic block diagram of an electrical variable speed drive. Different methods exist. These are, the first one is mechanical. Mechanical speed drive are basically designed in such a way that the motor, that you've got a motor which is the driver that connects to a device on the load which is driven, and these devices have different diameters, and by varying the relationship between these two diameters we can change the speed of the rotation. These are typically seen in our standing drills and pulley systems. The first one is a variable pitch drive, and basically you've got a whole bunch of pulleys of different sizes, and by linking the driver onto the driven by linking the driver on the driven. The diameters of these pulleys will then determine the speed of rotation on the output or on the driven side. Next is called the traction drive. This is very similar to gears, where you've got two metal rollers that mate, also with different pulleys, with different diameters, and that causes the change in speed as well as torque. So these are typically geared devices. A second speed, or a second method of speed control, is what we call hydraulic. Hydraulics refers to liquids basically how that one works is you've got your motor that links to a pump. The pump will then link to a reservoir, and the pipe that links the reservoir to the pump. The reservoir links back to the pump. So over here in this feedback we will put a valve. That valve will control the amount of liquid that passes through the pump, and by causing that resistance of the flow of the liquid, typically an oil, in the pump, we will generate or cause the motor to change its speed. Those three different methods in the hydraulics are called hydrostatic drives, hydrodynamic drives, and hydroviscous drives. Next method is electric speed control. The electrical methods first one is your DC drive. Okay, these basically connect onto the motor, and they connect to the motor, between the motor and the supply, and literally they are just a bunch of variable resistors that will allow the decrease in the amount of current, which in turn decreases the amount of magnetic fields generated, and as a result the speed is controlled that way. Second method is eddy current drives. In this method there's no physical connection between the load and the motor. We will have the motor, and from the motor we will have a drum-shaped field. This drum-shaped field is magnetized, and then, okay, that's the motor, and then the driven side we will have a second drum which magnetically connects to the motor driving drum, and then that will connect to my load. Now what happens is, as the motor turns, it induces a current into the drum on the driven side, which then turns the load. By adjusting the strength of this magnetic field, we will adjust the attraction or the eddy currents induced into this drum, which in turn adjusts the attraction, which means we are changing the speed of rotation. So this is technically an induction motor within an induction motor configuration.